Hi everyone, welcome to Dataverse Academy. In this video, we will be focusing on raw to clean notebook and data quality framework. So it's inside ingestion notebook and you can see raw to clean. So here in this notebook, which is raw to clean, I'm calling data quality framework notebook and log monitoring because I need to use both of them inside. And these are some Spark functions and types which we are importing in this notebook, just like file to raw. And these are some parameters which I need to pass to this notebook, and we need to convert it to as parameter type, which is system, which is going to be Coupa, table name that can be like transaction, transaction line, customer, or any of those tables. Then we have clean schema, which I have shown you while creating the config table, which is going to be like conversion from uh, string to integer, string to date, that kind of a schema will have. And then we have watermark column. So if you remember, in case of transaction or transaction line, we have this sys file timestamp. So that will be passed here, and watermark value, so which is 1st January 1900 by default. Then we have load type. So load type will be incremental for these two. Then we have key column, which will be for transaction. It will be transaction ID, and for transaction line table it will be transaction line ID, comma transaction ID. And for customer, we don't need the key column because that will be a full load. And for item also we don't need it. For vendor we also don't need the key columns, watermark column and watermark values. And then we have source schema, like it will be a source table schema which is raw, and it is target table schema which is clean, and this is config table schema which is config, and this is config table which is metadata table, and this is dq table, which is our data quality table which we have created, which is dq underscore rule something, and then monitoring table which is pipeline underscore monitoring. And then we are creating few variables here: raw table full name, clean table full name, and there will be new table which is quarantine table also. So this quarantine table will hold those records which are filled by data quality. Okay, so let's suppose from raw we have 10 records, and out of those 10 records, two got failed due to data quality checks. So those two records will be passed to quarantine, and the eight records will be passed to the main table. Then we have monitoring table name, and here we'll have one function for full load, one function for incremental load. Okay, so this one is for full load, and here you can see generate merge script. I'll show you what's the use of that. Then we have incremental load. Then at the end we'll have watermark table update, and after that, here inside this we are calling those particular functions like full load function or incremental load functions. We are calling inside this only. So now let me explain the use of full load function. So inside the full load, these are some variables which we have created. Okay, so it has some default value. Then we are checking if it's a full load. Then we are checking whether the clean table exists or not. So this will be true in case when you are loading the data second time, third time, because the table has been already been created in the first time. Okay. And now let me move to the else part, which is first when the table is not going to be created. So I'll explain the table when the table is created later. So let's suppose we loaded the data from file to raw. In the clean layer, we don't have any table. So this query will run select star from that particular table. So I'll take an example of customer. Select star from customer table from raw schema. Stored into the data frame. Now we'll execute this data quality check function over this data frame. So I'll explain this later what exactly we are doing in the data quality framework. Once the data quality framework check has been run on this DF data frame, we'll receive three things. Okay, so this will have all the logs, and this will have invalid records, and this will have valid records. So let's suppose if I pass 10 records from here, this will contain all those logs of those records, and this will have two records which are failed, eight records which are not failed. Then we are applying the clean schema only on the records which are passed through data quality checks. Okay, then we are writing that data to our clean table, main table, and this data is being written to the quarantine table because these are failure records and these are passed record from the DQ checks. After this, we are assigning the value to these variables like source row count, target row count, and DQ issue count and remarks, and then we are passing it to the logging function. And let's suppose now the table is already created. Now we have second time on the second day or maybe third day, you are loading the data again to the existing table. So if the table already exists, then again we have two cases. So I'll quickly explain what exactly is going here. Let me go to the notepad. So there are multiple cases involved here. First one is like clean table not exists, so we just loaded the data from raw to clean, which we have already discussed. And second case is if the clean table already exists. Okay, like first time load is done and then the clean table already exists and we have maybe some let's suppose we have files folder which from which we have readed the raw. So inside file we have readed this customer which is of 1st January, and which has maybe like 10 records or 20 records. Those had been loaded to raw, and from raw to clean we have loaded those 10 records. Now in the next run we are loading the 2nd January file which has maybe uh, 10 records again. So raw layer will have one system file timestamp and source from which we are loading the data. So then we will load those 20 records here and system file timestamp and sys file time, and also we'll have you can say one more column which is kind of what is the source file name and like that. So those 10 record has been loaded here. So it's a full load, right? So what we need to do, we need to drop those 10 records and insert those 20 records in the clean layer. So finally we'll have 20 records in our clean layer because in clean layer we always do truncate and load for the full load tables. Okay, not for the incremental. So this customer table is a full load. And in raw, we'll keep on appending the data, whether it's a full load, whether it's an incremental load. Now, there is a third case. So let's suppose someone has run a delete query here. By mistake, someone has deleted this particular data. Someone has deleted this particular data. Now you need to reload it. Now you don't want to like, because this file is already been moved to archive, right? When you run your framework, you will have 10 record and 20 records here. 10 records of first file and 20 records of second file. And from file to raw, there will be no new records because both the file has been moved to archive. And once you run your framework, it will first load this and from raw to clean. So how you are going to decide which is your latest records? So these 20 records. So you need to pick those 20 records, right? If there is no data inside the clean table, like somehow this will be deleted when you are going to do the second load, and we will have 20 records. But somehow some like person has done some maybe like delete query applied, run some delete query on this. So those 20 records also got deleted. Now we have zero records. So you when you run whole framework from here to here, zero records will be true. And from here to here, we need to pick those 20 records. So how you are going to pick this? So we know like we are maintaining sys file timestamp, right? This one, these 20 record will have latest file timestamp. So we'll check which record has the latest file timestamp and we'll load these records 20 here. So this is what we are doing here. So this else part is when we already have the data in the clean layer. So when you pick this sys file timestamp from the clean layer, it means we have some data in the clean layer, those 10 records. Okay. Now next time you are inserting the second file which has 20 records. So we need to pick those 20 records from the raw table. So you can see select star from raw where sys file timestamp is greater than max sys file timestamp, which is this one. Okay, so we are picking those 20 records, and if there is no data in the raw table for like greater than those particular records, let's suppose there is no new file comes from file section to raw section, then we'll have no new data. And let's suppose if we have some records, then we will apply data quality checks on top of this, then we'll insert that particular data. And there is the second case which we have discussed, like someone who has deleted the data from the clean table. In that case, this will be blank, right? So this next file timestamp will be blank. So if it is blank, then we need to pick the maximum file timestamp from raw table. And then we need to pick those records, only those records. We don't need to worry about other records. So if I'm taking example of this one, so I need to pick these 20 records, not these 10 records, because those are older records and these are latest records. Okay, so we'll pick those 20 records and apply data quality checks and all that stuff and load the data into the final table. Once that is done, we'll return those variables for the logging. Okay, now I'll move here. Uh, Here, yeah. So in case of full load, so you can see start time, pipeline name, run ID, layer from, which is raw, layer 2, which is clean, log, start, full load, and then taking those variables and then end pipeline. And in case of any failure, that will go here. Now we'll move to the incremental load. So in the incremental load, first default value to those variables, and we'll check whether the load type is incremental. If the load type is incremental, then we'll run this particular query. Why we are running this particular query? Can't we just take the incremental or latest data from the raw table? Why we are running this particular query? So I'll show you on the notepad. So if you remember, in case of incremental load, let's suppose first time these 10 record of 1st January, we have loaded the data file I'm taking. Okay, raw layer 10 record will maintain like 1st January. Then from raw to clean, again we'll load those 10 record, which is of 1st January. And this file will be moved to archive. Next time we have new 20 records, 2nd January file. Those records will be loaded here. Okay, will be loaded here in append mode, because in raw layer we will keep on appending. Now from here to here, from here to here, okay, we need to find out which is the latest records, right? So I can't take 10 records and 20 records again. So if you remember, in our metadata table we have watermark column and watermark value. So watermark column which we have is sys file timestamp. For the first time it was 1900 0101. So from here to here we picked those 10 records and we are updated it to 1st January 2025. Now for the second time we need to pick those records which are greater than this date. Okay, so we'll pick those 20 records and we'll apply upsert operation using merge. Okay, and based on that we'll insert the 2nd January records here. So let's suppose out of this 20 records 2 were updated records and 18 were new. So those 18 will be inserted new, and out of these 10 2 were all 8 and 2 have been updated because 2 records were updated one. Okay, so finally we'll have 10 plus 18 equals to 28 records. So now there is one more case, which is let's suppose third file came, which has 3 records. I'm just taking example of 3rd January, and it has records like which is transaction ID. Let's suppose uh, you receive multiple files on the same day. So what I mean is transaction underscore 2025 3rd January, and one is 12 a.m. files and another, sorry, 11 a.m. and another one is 11:15. Okay, so these two files came. Now it might be a scenario, uh, in transaction table we have transaction ID as a key, right? So same ID exists here and same ID exists here, 1 and 1. And we know this record which is inside the latest file is our latest record. Okay, so it, and there is one more case. So let's suppose there is a transaction ID 2 which exists here but not exists here. Okay, and there is another case which is like third 3 which is not there. So what we need to do, we need to pick, in case of 1 we need to pick this one, 2 we need to pick this one, and third this one. Okay, so that's why I have this partition by, like partition by key column, and pick the latest record based on sys file timestamp. Okay, this part. So I'm doing the partition by this one and picking this latest record. So we'll pick 1, 2, and 3, and then we'll upsert that particular. And this particular part, which is like uh, taking the latest data from the raw to clean, is done through this part where watermark column is greater than watermark value, which is this one. So watermark column is our system file stem is greater than 1st January 2025. So it will be like select star from this one. Key column is transaction ID, order by sys insert timestamp, and from raw table where sys file timestamp is greater than or 1st January 1900. Okay, so that's why I've created this particular query so that it can handle multiple scenarios. Which first one is picking the latest record, and second one is when we receive multiple files on the same day, so that we can pick the latest record for from a latest file. In case if the same ID exists in both files. Now we'll move to the else part, where let's suppose this data frame is empty. If data frame is empty, it means we don't have any records which we need to pull from raw to clean. And if we have some records which we need to move to raw to clean, then we'll apply data quality checks on top of that. Okay, then why I'm creating this view, I'll give an example. Okay, so then I'm creating this view which is temporary view inside the PySpark notebook which will not be created in your lakehouse. Okay, it's a temporary view which will be used inside this notebook. So view name will be view underscore Coupa underscore transaction underscore 10. Once this view is created, so we'll be taking the source count from this source query, okay, with this query, and then we are taking the valid count, and then we are taking the invalid count, and then we are marking data load has been done to this particular thing there, and we'll move to the part when the clean table doesn't exist. So what exactly we are doing here? So here we are first taking the uh, schema, which is like this one with clean and all that. So I'll quickly show you. Let me open a lakehouse, and here in config you can see our metadata. So here you can see our this one. So this is a clean schema, right? With column converting string to date and converting string to integer. So that kind of. Now I'll go to raw to clean. So once we receive the clean schema, then I'm writing it to my clean table. Once the initial load is done and table is created, now what I need to do, I need to generate the merge script for the upsert operation. Why? Because for the first time it will be a simple load. Whatever you have in the raw table, just insert that data into the clean table. But from the second load, it will be a upsert operation. Okay. So here I'm checking like if I have any merge script for that particular table, just delete that merge script because I need to uh, generate. Okay, someone let's suppose have deleted some data from our table or maybe drop that particular table, and now we are going to create that particular table again. So I need to delete that merge. So I need to generate the merge script for the second operation, which is this one. So first time 10 records pull from here, 10 record inserted here, and 10 record inserted here. So for that first time we don't require the merge operation, right? It will be required for the second, third, and fourth part. And now we will see how we are generating this merge script. So let me go to the notepad. So the merge script will be required for upsert operation whenever is if there is any uh, new data or updated data which is coming from the source system. So in our case, we are moving the data from raw to clean layer, and in this we need the merge statement for incremental load. So what exactly is merge script? So if you have worked on SQL, you must be aware about it is merge into your target table using source table or query or source view, and then join condition on key columns. Okay, this will be target and this will be source key. Then and then we'll have and then we will have when matched, then update records, update, set, and whatever columns you want to update in the target. So let's suppose if I have ID, name, and salary. So ID is used in join condition. I want to update name and salary. So here it will be like target dot name equal to source dot name, comma target dot salary equals to source dot salary. And then next condition after this we'll have when not matched, then insert here, and then we'll specify columns, and then we'll specify values. So these value will be source column, and this column will be target column. So we'll make this dynamic. So what are the things which we require to make it dynamic? Which is this one, target table name, and our source table or source query or source view name, and what are the key columns, and what are the columns which we need to update, and what are the columns which we need to insert. Okay, other than that everything will be static. And here we'll go to the generate merge script function. So here you can see what I'm doing. I'm first describing my source table. So we know like our source table is already get created with all the data types and columns. So we need to create the clean table with the same columns as it is, which is created in the source. So we'll take the column names from the raw table. So for that's the use of this describe command. It will give you column name and what's their data type. We don't care about the data type. We need the column name. And this is the temporary view. On top of this, we'll build the merge statement. So this will be used as a source query. So here you can see this one. Okay. So same name we have given for the merge query. Then in the merge statement, we require the target table. So and we require the source table and then key columns. So this statement is for key columns. So at the top, we were passing the key columns like transaction ID, comma, transaction line ID. So that has to be split and converted into array. So that has been converted to array, and now we have created this join condition. So it will be like key one equals to key one and key two equals to key two. Then we need to have these three more clause. One is this update clause, which we like write update set and whatever the columns name we require. So this will go for that. And this is insert clause target, which are like insert column and then values, insert columns from the source. Okay, so then we are going through this schema, and we are taking the column one by one, and we are creating the update clause, and then we are creating the insert clause, and we are creating the insert target columns. So if I go to my notepad, we are creating this. We have already created this. Now we are creating this part, because these are target columns, and this is source columns. Okay, so we are creating these three parts. So these three we have already created. Here key created, like join condition created, and this source is created, and we'll have the target table as well, which is clean table, which we have declared at the top. And so these three are created, like insert source clause, insert target clause, and update clause. And then I'm just removing the new lines. If there is any new line which can create an issue, then I'm putting all these things in my merge statement. Merge clean table is my target table, source view is my source query or source table, you can say, and then join condition, then update clause, and then insert target clause and insert source clause. And then I'm inserting this data into my config table. You can see Lakehouse, config, schema, and config table. Okay. So this is what we are doing in the merge script, and this will be run only once when the table is getting created. Once a table is created, we will not be calling this particular function, because our merge statement will be there in the config metadata, and we'll use that merge statement to do the upsert operation. After this, like once your incremental load is done, here you can see incremental load is done, then we again doing the same thing. Like start, we have already done the logging, and then end logging. into the pipeline monitoring table. If there is any failure, then we'll catch as an exception and then we'll put it in the monitoring table. Once our load is done, so here you can see inside the incremental, like I need to update the watermark in case of incremental. There is no need to update the watermark in case of full load. So I'm calling this watermark update inside my incremental load. Once like all the data has been written and we called this, you can say, like written the data in the final quarantine table or in the main table. After that, I'm calling my watermark. So what I'm doing in the watermark, I'm just updating my metadata table with the maximum sys file timestamp or whatever column you specified as watermark into the config table, maximum value of that. So we are, so if I gave you an example, for first load, if we have 1st January data, 10 records, we inserted those 10 records to clean table. Then what we'll do, we'll take the maximum of raw, whatever maximum, you can say, sys file timestamp or any other column which is you have specified at watermark, and we'll update that in the config table. And next day, let's suppose for 2nd January, you have again 20 records. So whichever is greater than 1st January, we'll pick those records and we'll do the upsert here. And then again, we'll update this to 2nd. So this is what we are doing in a watermark. So this is all we have in a raw to clean layer. One thing which is left is data quality checks. So we have not discussed about the data quality checks yet. So let me show you what exactly we are doing in our data quality checks. So from here, if you see, we are just passing the whole data frame in a for the data quality checks, which is this one. Okay, I'm just giving an example for incremental load. So we are executing this particular function, and here we are passing the sort, like the whole data frame, which we need to validate, and then we have Lakehouse name, which we are passing. Then we are passing config schema, and then DQ table, and our final, you can say, table name, and on which layer we are applying this. So it's clean, like we are moving the data to raw to clean. So we are applying in a clean layer. So that's why I've specified as clean. Now, if I go to my data quality framework, this is the code for data quality framework. So at the top, you can see we are importing some PySpark functions, some data types, and repackage. And we have few functions here. I'll come to those functions one by one. Now let me go to the end, and here you can see this is the function which we are calling in the raw to clean layer for even for the full load or for the incremental load. So you can see we are passing data frame, lakehouse, config schema, config table name, and on which table we want to apply that, and which tier. So first we are creating our input config table, uh, which is our configuration table. Okay, and then here I'm calling this particular function, which is DQ load DQ rules from table. So if you remember, we have a data quality checks table in which we have specified the data quality rules. So I need to take all those rules into this particular data frame, or you can say, like we'll see like what exactly we are returning, whether we are returning a data frame or it's a dictionary. So we are passing the input config table name, and on which table we want to apply that, and then tier. Okay, so here we are passing the data quality check table name, and this is the table name on which we want to apply. So These two are different. This is data quality checks table from which we'll select the data, and this is for which particular table we are applying this to. So let's suppose if I put data quality checks rules in DQ config table for transaction and transaction line. So this is data quality checks table, and this is if I want to check on transaction, this is transaction table. Now I'll move to this particular function. I'll show you what exactly we are doing. We are just simply selecting whatever the rules we have in our data quality checks in a particular order. So I'm reading this particular data quality checks table. Then I'm filtering the records for my input table, which is like, let's suppose two tables were there, transaction and transaction line in uh, DK rule, but I'm interested in only transaction table. So I'm filtering those records. So I have selected all the DQ checks which I need to apply on transaction table. Now here you can see again I'm putting a filter where the active flag should be true. So out of maybe like five uh, checks if I applied on transaction table, four are only active. So I'm interested on those. Then this is some kind of a dictionary which I've created, like what is the column ID, like rule ID column on which we are applying. Then what is the check type, what is the label, what is the type, expected severity. So this dictionary which I've created. Here we have two conditions. If the check type is range, then I'm doing this computation. If the check type is either format, type, or domain, I'm doing this particular if the check type is format, type, and domain, I'm doing this particular computation. And at the end, I'm appending all the rules and returning as a dictionary to that particular function. Now we'll go and check what exactly we are doing inside this function. So here you can see we are just passing the original data frame and our rules which we have written from the our function in dictionary format. And as you remember, these are some columns which we are adding in a raw table as well as in the clean table, which is row number of the records in a particular file and system timestamp and sys insert timestamp and source, which is like Coupa in our case. So if these columns are missing in the data frame, then like we'll pass it as a missing traceability column. We'll raise an exception, and let's suppose these columns are already there. Then we have created a dummy data frame with these columns for our logging part, which is row number, file timestamp, source, rule ID, column name, what is the issue in that particular column name, and what is the check type, what is the severity of that particular rule. Then we have created this data frame, empty data frame, and after that you can see we will apply rules on each row. So we have multiple rules, so that's why we are doing a loop over those rules and we are applying those rules on each row of the data frame. So the first one is it's not mentioned in the DQ check, but it's just to check whether that particular column present in your data frame or not. So by mistake, if you have mentioned a column in your DQ config table which is not present in your actual table, let's suppose if I have ID, name, and salary in my actual table and I have put a data quality check on address, but that column is not present, right? So this is to check that. And after this, this block is to check for a column which is not nullable and we are having a null value in that. And this one is for format check. So if the format is email type, so we'll check the email whether it's a valid email or not. So for that we are calling our this function is valid email, and here we are checking whether it's a valid email or not. And we are making this valid email as a user defined function. Okay, So this can be used anywhere within our workspace. Once it has been defined as an UDF, you can use that particular function anywhere. So after email validation, we are checking for the range. So which is like in our case, we have put on subsidiary. It should be 1 to 6 only. If if there is any beyond that, like either 0 or 7 or 8, it will be filled by the DQ check. Then another one is type check, which is other than email type check. It's for like date check, integer check. So that kind of a check will do. So if it fails, then we'll move that particular row to the quarantine table. Then we have domain check. So in our case, we have put it on transaction type, where we are checking transaction type should have values in those specified uh, data. So if I show you the table, DQ check table, let me go to the Lakehouse. So you can see we have put these four DQ checks on our transaction table, and this is the domain one where we are checking like whether it's general, check, vendor bill, and we have multiple here. Okay, so if it's not inside these particular values, then we'll so you can see check, vendor credit, vendor bill, and in transaction type, only these values are allowed. If we have values other than that, with that rows will be moved to quarantine table. Once all the checks are applied, we are returning that particular data frame because we are kind of doing the union in the single data frame, which is log data quality log data frame, this empty data frame, and it will have all these rows, like in which row we have that particular error, or what's the source, and in what rule has been failed, in which column we have faced an issue, what was the issue, and what's the check type and severity. So once all the checks has been applied, we'll returning this data frame to the original function, which is this one. So we'll receive all the data in logdf. Once we receive the data in the logdf, we are doing the group by just to put all the errors which is on a particular row. So what does that mean? It might be a scenario in on a single row there are multiple failures. So if I say like ID, name, or salary, so ID will not be null. So if it is null, then we have a nullable check. Then on like let's suppose if I have a date, birth date, which is not valid, then on the same row, birth date type failure is also there. Then if we have applied some domain check, then domain failure is also there. So we need to put all those issues in a single column. So that's why we are doing the group by based on row and source, and then putting that in a issue summary. Okay. So we have issue and column name in different columns. So we are putting it in one. Then we are clubbing all the issues in one column, which is issue summary. So it will be like row number one. Source will be Coupa, and what are the failures like null value failure, comma, domain failure, comma, date type failure. So in this way. Then from this particular data frame, we are deciding which is valid. So this data frame will contain all the invalid records. So from the main data frame, which is DF, we need to find out which are valid and invalid. So that's why we are joining our main data frame with this group log DF and finding out which are invalid. So using inner join, we can find out invalid records, and using left entity, we can find out valid records. Then we are returning this log df, invalid df, and valid df. So we are using valid and invalid df to writing it to the main table and the quarantine table. So this will write to the main table and this will write to the quarantine table. So this one I'm returning just to make sure, like suppose if anyone wants to check data in the raw to clean table, like what are the logs has been generated. so they can use that. So if I go to raw to clean, here you can see, yeah, log df and valid and df. So we are writing, you can see uh, this one, writing to the quarantine table, and df you can see we are writing it to the main table, first doing the transformation, like specifying all the uh, clean schema, then writing to the main table. So this is all about our data quality framework. That's it in this video. Thank you. Please like and subscribe. And in case of any suggestion on improvement or in case of any doubt, please comment.